Lifestyle-based approaches can reduce the risk of chronic disease and as such are a key element of a long and healthy life. From addressing potential micronutrient inadequacies to following personalized nutrition and exercise plans, a range of lifestyle therapies may benefit an individual's health span.
I think that if there's a message here, it is that the most important thing that you can do in your life is to sweat and get physically active. Like there's nothing that is going to be better for you. No aging drug, nothing's going to be better than what exercise can do at the moment.
On this episode of Pathways to Wellbeing, we welcome Dr. Rhonda Patrick, a widely published researcher and health educator, to discuss healthy aging and longevity using proactive, prevention-focused strategies. At IFM's upcoming annual international conference, Dr. Patrick will outline new advances in using hot and cold therapies and the resulting beneficial effects on the brain, metabolism, and immune function. We're excited to hear a preview of this fascinating topic today. Welcome to the show, Dr. Patrick.
Well, thank you so much. I'm excited to be here today and discuss all the very important topics that you just basically mentioned.
Well, I think this is really exciting and there's a lot to unpack. So we'll just get right into it. And I thought it would be great for us to start with kind of a general contextual overview of how lifestyle changes can impact healthy aging, because I think it's so powerful that even bite-sized, approachable lifestyle changes can potentially improve our health span and our well-being and even our cognitive and physical performance. So let's just dive right in. And in general, will you tell us some of your favorite go-to lifestyle-based longevity tips?
Well, I think there's, it's important to consider low-hanging fruit. So things that there's not a lot of resistance and barriers for people to start applying in their daily lives. And I think when it comes to some of the easiest things that people can do, it usually comes down to, unfortunately, taking a pill. And so I know you might be going, what is she talking about? Well, the micronutrient inadequacies it's a widespread problem in the United States and other developed countries as well, where, there's about 30 to 40 essential vitamins, minerals, fatty acids, amino acids that we have to get from our diet. And if we don't get them from our diet, we are going to be inadequate in them. And these essential micronutrients are doing very important things in our body, from running our metabolism to making sure our enzymes, which are proteins inside of our cells that are basically doing all the work responsible for everything from pumping our blood to our immune function to neurotransmitter function. So basically everything. They require these, micronutrients as cofactors. And it's definitely, I think, safe to say that diet, food first approach and getting all your micronutrients from whole foods, eating diverse foods is paramount. However, many people, for whatever reason, they will not do that. They're, busy, or they have a habit, or there's, other sorts of dysregulation, perhaps in satiety mechanisms. And, so getting some micronutrients, like some of the important ones from a supplement, and these are easy ones. Vitamin D is an easy one. That's something that we usually make in our skin from the sun. And about 70% of the US population has inadequate vitamin D, and that's kind of defined as less than 30 nanograms per milliliter. If you're in the United States, if you're in Europe, you'd have to multiply that by 2.5. But 70% of the US population has levels below that. And there have been many different meta-analyses, over the decades, dating back all the way to the 1960s, looking at vitamin D levels and all-cause mortality. And it's pretty clear that having levels above 30 is associated with a lower all-cause mortality. In other words, people are less likely to die from non-accidental causes of death, whether that's cardiovascular disease. Although I would say cardiovascular disease is probably the weakest with respect to vitamin D. Cancer mortality is down, respiratory disease is down. Those are two of the really big ones, the big drivers with respect to lowering all-cause mortality. But so taking a vitamin D supplement is one of the easiest things to do. Why is widespread deficiency, so common? Well, because we're inside in our cubicles, in our offices, at our, with our technological advances, computers, everything. We don't spend as much time outside, doing agriculture, doing, the sort of outdoors kind of jobs that, that were common 100 years ago. So people are not making vitamin D from their skin. And on top of that, there are a variety of factors that actually regulate whether or not we can make enough vitamin D in our skin. And that, from everything from age. So a 70-year-old person makes literally 25% of what they made as their 20-year-old self. So it's very inefficient as you get older. Skin color, so melanin, that pigment that basically acts as a natural sunscreen, also is a filter for UVB radiation, which is actually what needs to basically penetrate through the skin to start vitamin D3 synthesis in the skin. So because melanin is a natural sunscreen also does that. People wear a lot of sunscreen nowadays. So there's many different reasons why people are not getting as much vitamin D in our modern day world. And vitamin D is one of the cheapest and easiest supplements to take. There have been studies that have basically tried to figure out, how can you take a person who is deficient? So deficiency would be 20 nanograms per mil or less. And when you start to get less than 20 nanograms per milliliter, you start to run the risk of, bone problems and other types of severe problems, immune dysfunction, for example. People that are deficient and supplement with about 4,000 IUs per day can bring themselves up to a sufficient level, closer, above 30 nanograms per mil, perhaps even closer to 40. And 4,000 IUs per day is actually the tolerable upper intake set by the Institute of Medicine for vitamin D3. And I just want to mention, vitamin D is unique among the vitamins because it gets converted into a steroid hormone. So vitamin D3 goes to the liver. It's converted to another metabolite called 25-hydroxyvitamin D. That's the major circulating metabolite of vitamin D. That's usually measured if you get a blood test. And then it goes to the kidneys where it's then converted into the steroid hormone. That's 1,25-hydroxyvitamin D. And what I mean by a steroid hormone, most people think about estrogen, testosterone. Those are steroid hormones. Imagine if 70% of men in the United States were deficient in testosterone. They would be terrible. So, vitamin D is basically very different because it basically can enter what's called the nucleus of a cell. And that is where all your DNA is. And it can basically recognize this little sequence of DNA. And it basically, binds to a receptor and, it binds to your DNA and turns genes on, activates them, and turns other genes off and deactivates them in this coordinated fashion. And these are genes that are important from everything from brain function. So serotonin is one. It's important for the synthesis of serotonin in the brain, to immune function. And it's why vitamin D plays such a critical role in helping prevent respiratory diseases. And so low-hanging fruit there, vitamin D, easy one. Another one that's pretty, I think, common in the United States, at least, for example, is magnesium. And magnesium is an essential mineral. About 50% of the US population does not basically get adequate intake of magnesium. And the RDA for adequate intake was set at around, I would say on average, it's a little different for males and females, but on average about 400 milligrams per day for an adult. And if you are a physically active adult, so let's say you exercise frequently, you are, maybe using the sauna, you can excrete magnesium through sweat. And so physically active adults actually require anywhere between 10 to 20% more than the RDA. So you can imagine if people are already not even getting the RDA, The physically active people are even, in worse shape in some respects. And magnesium is an essential cofactor. It's a mineral that is important for the function of over 300 different enzymes in our body. Everything from enzymes that are important for repairing damage to our DNA. So DNA damage is something that's happening every day. It's happening right now as we're having this conversation. It's not something that you can look in the mirror and see, but it is insidious in respect with respect to basically it causes this low level type of damage that accumulates over time. And as we age, it can lead to dysfunctional cells. It can lead to potentially what are called oncogenic mutations that can lead to cancer. So repair enzymes do not work properly without magnesium. Also DNA synthesis. So we're making new cells, we're making new blood cells, we're making new immune cells, we're making new skin cells. Every time we make a new cell, we have to replicate all the DNA inside of those cells. And that requires enzymes called DNA polymerases. Those are, you basically need magnesium for those to work properly, So again, it's a very important process for our DNA and repairing the DNA and making sure it doesn't get mutations from the get-go with DNA replication. And it's probably why there's a variety of studies that have found, these are observational studies. Of course, all the caveats that come with observational studies, like there's, potentially other confounding factors. But with that in mind, people with the highest magnesium levels have a 40% lower all-cause mortality and a 50% lower cancer mortality compared to people with the lowest magnesium levels. There's another study that I think it was specific to pancreatic cancer. So for every 100 milligram decrease in magnesium intake, there was a 24% increase in pancreatic cancer incidence. So again, sort of highlighting the important role magnesium plays, particularly with our DNA and, with respect to making sure the integrity of our DNA, the genomic stability of our DNA is good. And that's very important for preventing cancer, which is an age-related disease. It's something that you want to try to do everything you can to prevent. Of course, there are things outside of our control. However, there are things that are in our control. And I think, an easy thing would be magnesium. So why is widespread deficiency common? Magnesium is found at the center of a chlorophyll molecule. Chlorophyll is the molecule that gives plants their green color. So magnesium is high in dark leafy greens. Most people are not eating multiple servings of dark leafy greens daily. It's also pretty high in legumes. Almonds are another great source of magnesium. Oats are a great source of magnesium. So the bottom line is people aren't eating enough of their leafy greens. Supplemental magnesium is another possibility, but the dose of that needs to be considered because magnesium at higher doses can cause adverse effects like GI problems. So what I like to do is try to get my magnesium from dietary sources. Like this morning, I had a smoothie with some cooked kale. I had some chard in it. I had a couple of frozen strawberries and blueberries and avocado. So I was getting a magnesium dose with my breakfast, right, which was scrambled eggs. So, trying to find any way you can to get multiple servings of greens or almonds, oats are another great dietary source. But I also do a supplement of about 125 milligrams of magnesium, and I do magnesium glycinate. Most of the magnesium supplements are, with respect, I would say the one that's not very bioavailable is magnesium dioxide. But you could, magnesium glycinate's a really good bioavailability, has very good bioavailability. So does magnesium malate or magnesium citrate. So with respect to supplementation with magnesium, it can be a way to kind of at least get you up to more of an RDA adequate level. Also, when I sauna, when I'm physically active, I also drink electrolytes after that. And that's another, so you can have an electrolyte drink that replaces some of the lost sodium and magnesium, potassium, for example. So that's also another option when you're also physically active. So that would be another example, low-hanging fruit, with respect to important micronutrients. And there's another one, omega-3, we can get into, but I probably will speak a lot about that. So maybe I'll skip to the exercise as well. Maybe we can go into depth about those. But exercise is probably the biggest and most important thing. irrespective of anything else. I think being physically active, very clear, is the most important thing for healthy aging, for staving off dementia, for staving off cancer, for staving off cardiovascular disease, all the age-related diseases. It does require a little bit more effort, and I would love to dive more into specifics on that. But I do feel like I need to give you a chance to talk because I've already kind of gone on for a while. I would like to dive into the omega-3 and some exercise more as well, though, if you had any questions that you wanted to kind of ask me about that.
Yeah. That's awesome. I just so appreciate you centering this on these low-hanging fruits that are so accessible, really approachable. And this is one of the ways that we can really support longevity is by optimizing our micronutrient status because of all of the relationships with all-cause mortality that you talked about, chronic infection, cardiovascular disease, cancer. So I think that that's a super important place to start. As we're on the topic of personalized functional nutrition, will you talk to us a little bit, and this will probably lead into a discussion on omega-3s, but first, I'm hoping we can take some time and look at the food genetics relationship and talk about how that might play into healthy aging for any individual.
Yeah, I think so there are a variety of, we all have differences in our genes, and they're oftentimes just a change in what's called nucleotide, a nucleotide change in the sequence of DNA. And it's often referred to as a single nucleotide polymorphism. So a SNP, we call it for short. But it's kind of what's, differentiating between why some people have brown eyes or blue eyes or blonde hair or red hair. But in addition to those phenotypes and characteristics, there's also a variety of SNPs in genes that are involved in metabolizing micronutrients like magnesium, vitamin D, omega-3. But, in addition to micronutrients, macronutrients as well. So people are very different in the way they respond to foods. I think we, in general, when I say we, the scientific community is really in its infancy in understanding the interaction between our genes and our environment. And, so there are things that there are more, I think, certain SNPs we know a little bit more about than others, but it's hard, again, we're really at the infancy in understanding that interaction. It's a very complex interaction. But generally speaking, because I mentioned vitamin D, that is, one that is, there's a variety of very common SNPs that people do not convert the vitamin D3 into the 25 hydroxy vitamin D very well, or they do not convert the 25 hydroxy vitamin D into the steroid hormone very well. And I've actually seen blood work data from people that, friends even, that had to supplement with a much, much higher dose. So I mentioned 4,000 IUs being the tolerable upper intake that the that the Institute of Medicine set. Well, I've seen people have to take, between 20 to 30,000 IUs a day to even just get a normal 30 or 40 nanogram per milliliter blood concentration of 25 hydroxy vitamin D, because they have a genetic polymorphism that makes them so inefficient at doing that. In fact, there's been what are called Mendelian randomization studies. And these are studies where scientists look at these SNPs, these genetic variations that are typically involved in nutrition. They're involved in the metabolism of some, vitamin D, or they're involved in some kind of environmental factor. And what scientists do is they say, look, we have all these people. We know some of these people are low in vitamin D because of a gene, not because they're not outside and physically active, or not because they're not health, conscientious and supplementing, but it's their genes. And so it's kind of a way of randomizing people in a very, unbiased way that's random and just based on their genes, right? So these Mendelian randomization studies have found that people with genetically low vitamin D levels, have a higher all-cause mortality they're like, 25, they've got like a 25% higher mortality from respiratory disease. So it's really kind of, I would say, supporting and reinforcing the observational data showing that when you actually measure someone's low vitamin D levels, irrespective of their genetics, you see the same thing. So it's again, the genetics, the interaction between our genes and our diet in its infancy. But really, I think the important thing here also is getting some blood work done. Like, unless you go and measure your vitamin D levels, you're not going to know how deficient, or if you're deficient or insufficient you are. You're not going to know how well a supplement is raising your levels. Like, is it even doing anything? So measuring vitamin D levels before and after are very important. And the same goes for omega-3. There's omega-3 it's probably, I think, one of the most important, nutrients that is really overlooked and it's understudied, and people just don't even really think about it. Vitamin D has been getting on the radar. So omega-3, there's 3 types of these fatty acids. There's the type that you can find in plant sources. So that's alpha linoleic acid, ALA. And then there's the EPA, which is eicosapentaenoic acid, and then DHA, which is docahexaenoic acid. And those are the 2 marine sources that you'll find in fish, but also you can find them in microalgae, which is more of a plant-based source. There was a study that came out of Harvard, I think it was 2009, which identified the marine sources of omega-3 as basically one of the top 6 preventable causes of death. In other words, people are not eating enough seafood and fish. And because of that, it was calculated that about, I think it was something like 84,000 deaths per year were attributed to not getting enough EPA and DHA from the diet. And this was really comparable to people that were eating trans fats. Everybody knows trans fats are bad. You walk into any grocery store, it's 0 trans fats on every packaging thing you can see. It's very much in the public awareness that trans fats are bad. Well, trans fats were responsible for the same number of deaths as not getting EPA and DHA. So it was responsible for 82,000 deaths per year. Before I kind of go deeper into that, I mean, it's kind of just, but that makes you think about it. It's like, oh, wow. So the same number of deaths were attributable to eating trans fats as not eating enough EPA and DHA from marine sources, fish, for example. And it kind of really makes you think about things, because you don't walk into a supermarket and nothing says, oh, this isn't seafood, this isn't getting your EPA and DHA, this is processed, but yet everything tells you about trans fats. And it was, just as important to get those, omega-3 fatty acids from marine sources. Now I say marine sources because ALA, which is the common source of omega-3 found in plants like flax seeds, walnuts, for example, that is actually considered the essential fatty acid because we can convert ALA into EPA and DHA. And so, all the government agencies that comes up with these RDAs and, all those standards that are set, basically it goes down to, oh, well, because we can make EPA and DHA from ALA, that's going to be the one that we focus on. The problem with that is that the conversion of ALA into EPA and then subsequently DHA it's very inefficient, and there's a widespread genetic differences with respect to that conversion. So some people are great. They have a alteration in the desaturase gene that does the conversion of ALA into EPA, and they do it quite well. I would say the majority of people have another version that are not so great at it. And to kind of add fuel to the fire, having too much of vegetable oils, omega-6 fatty acids, I don't want to demonize them so much, because you need linoleic acid, you need arachidonic acid. It's part of your cell membrane. They have important functions. Getting them from whole food sources like walnut, like nuts is great. But the vegetable oils are very, very concentrated, and a lot of cooking. If you eat out, if you buy processed foods, they're usually cooked and processed with vegetable oils. That omega-6, when it's too high, can compete with that enzyme that's required to convert ALA into EPA. And so you may be getting enough ALA. By the way, that's the other problem. People aren't even eating flaxseed and walnuts. They're not even getting enough ALA. So there's so many layers to this. There's so many layers. But that conversion is very inefficient when there's a lot of omega-6. And on top of that, I would say the one saving grace there is that estrogen does dramatically increase that conversion. It makes it, it's 20, like up to 20% better. And so this is probably because DHA is so important for brain development. And when a woman becomes pregnant, estrogen skyrockets. It's like 100 times higher than what it normally is. It's pretty apparent that nature has figured out a way to at least convert all that ALA as possible into EPA and DHA. Anyway, so that's where the genetics comes in. There's definitely a regulation there. But on top of that, I think the best way, to get the EPA and DHA is from eating, a dietary source and measuring what's called the omega-3 index. So the omega-3 index is measuring omega-3 fatty acid levels, the EPA and DHA, and there's other fatty acids as well, but in red blood cell membranes. And it's really important because most of the time when you go and get a omega-3 blood test, the plasma phospholipids are measured, which is better than nothing. But you're really looking more at your dietary intake in the last week or two versus red blood cells, which are 120 days before they turn over. It's a long-term status of your omega-3, kind of like the difference between looking at fasting blood glucose and your HbA1c, right? Like fasting blood, you could have had, you've been intermittent fasting for that day and your fasting blood glucose looks great, but is that a snapshot of what your daily blood glucose levels always look like? Might not be, right? So long-term status, omega-3 index, and there's been a variety of studies from Bill Harris, he's the co-inventor of the omega-3 fatty acid test. I had him on my podcast about a year ago. I've actually joined the Fatty Acid Research Institute, which is a nonprofit institute studying a variety of the roles of fatty acids in human health. I've joined as an associate researcher, and so I'm doing some studies on omega-3 and brain health. But Bill has published a variety of studies looking at omega-3 index and all-cause mortality, cardiovascular related mortality. So I would say when you get the omega-3 index measured, most people in the United States have an omega-3 index of less than 5%. And what Bill has shown from multiple studies is that people that have an omega-3 index of 8% have a 5-year increased life expectancy compared to those that have an omega-3 index of 4%. So 4% versus 8%. There's also evidence that it's related to cardiovascular related mortality as well. But also a very interesting piece of data that Bill published was looking at smokers. And everybody knows smoking is terrible for your health. Like what can you do to accelerate the aging process? Like smoking, right? Smoking, cigarettes, tobacco it's terrible. And this was so interesting. The omega-3 in smokers that had a high omega-3 index, so they were smoking, but they were also eating a lot of fish, supplementing with fish oil. They had an 8% omega-3 index. They had the same life expectancy as non-smokers with a low omega-3 index. In other words, smoking was like being deficient in omega-3. I was blown away by that. Like there's a beautiful graph in the paper. I forgot what journal it was published in. It was a couple of years ago, but it's just kind of mind blowing. So omega-3 is, there's so many different roles that it plays in the body. It accumulates in cell membranes, plays an important role in the way transporters and receptors function because all those things are embedded in the cell membrane. And so, for example, glucose transporters at the blood-brain barrier are altered. They're not functioning well when DHA is deficient. And that can cause, less glucose to get into the brain. That obviously leads to many problems. It's also the metabolites of EPA and DHA are these specialized pro-mediating, they're specialized pro-resolving molecules. And so they resolve inflammation in a very efficient and timely manner. These are the myrisins, the protectins, they're the SPMs, the resolvins. These are playing a very important role in inflammation. And I think there has been now enough evidence that inflammation, chronic low-level inflammation, is a driver of the aging process itself. In other words, not just driving, increasing the risk of cardiovascular disease and dementia and cancer, which it does, but just the process of aging. And so it's affecting all those things. And, inflammaging is a term that's used, which is kind of like it's the activation of the immune system is accelerating the aging process. And it's known as inflammaging. There's neuroinflammation. And there's been like these 7 pillars of aging where you look at all these like physiological processes that are happening, like genomic instability is one, protein misfolding is another. And there's also this neuroinflammation. The only thing that was really overlapping between brain aging and just aging itself was the inflammation. That was the most important thing that was accelerating, everything in the brain and also aging, in the body. So having omega-3 is, I think, one of the easiest things that someone can do to improve their inflammatory process, to improve the structure and function of their transporters and receptors. And I know you're going to ask me some research I'm most excited about. I'll give you a preview of that. I'm also excited about a new role of omega-3 in muscle mass and also sensitizing amino acids in skeletal muscle. So there's been some work from Chris McGlory, who I had on my podcast just yesterday. He's actually shown that omega-3 is playing a role in disuse atrophy and through a mechanism where it's not inflammatory. It's not the, anti-inflammatory effect of omega-3. It's actually doing something anabolic. It's somehow affecting muscle protein synthesis. And he thinks it's actually sensitizing muscle to amino acids through some unknown mechanism they're trying to figure out. So I think I'm pretty excited about that new research coming out. Muscle mass obviously is an important factor in aging as well. But I do think that, so when it comes to omega-3, what do you do? I mean, obviously, if you can eat fatty fish that's high in omega-3, salmon, mackerel, sardines, these are all pretty good sources of omega-3 that are also low in contaminants like mercury, PCBs. By the way, there have been now studies that have come out showing that even though fish have, these contaminants, that the omega-3 fatty acids protect against them, and even during pregnancy. So there was this big push, decades ago about pregnant women should avoid eating fish because of the mercury. I think that was a huge mistake. And I'm actually involved in a study looking at omega-3 index in cord blood and neurodevelopmental outcomes. But there's been a couple of studies, one I think big one was in 2015, American Journal of Pediatric published that basically the omega-3 fatty acids, women eating fish, the omega-3 fatty acids protected against any neurotoxicity. And in fact, those children had, better neural outcomes than women that avoided fish. There's also been studies looking at omega-3, like fish intake and intelligence in fish intake during pregnancy and intelligence, at 1 year or 7 years of life. I forgot all the, the follow-up times, but it was shown that, omega-3 was correlated with improved intelligence if the mothers were eating fish, and they were actually using mercury as a biomarker to basically validate their dietary recall, because the women that were taking in more omega-3 had higher mercury. And guess what? The higher mercury was correlated with higher intelligence in the children, not because mercury is improving intelligence, but because the omega-3 is. And the omega-3, the mercury doesn't even matter if you have the omega-3 there. It's really protecting against any potential toxic effects of mercury. So I know that was a bit of a tangent, but it's important because people are kind of scared of eating fish. And, there are some fish that you should be scared of, like swordfish, which is terribly high in mercury and not so high in omega-3. But things like salmon, wild caught salmon is low in mercury, high in omega-3. Also supplementing is I think a really important option. So looking at the 4% omega-3 index, comparing it to the 8%, I mentioned the 5-year increased life expectancy. I think that there's been some studies showing that 1.5 to 2 grams a day supplemental omega-3 can bring people from a 4% omega-3 index to an 8% omega-3 index. Now, to keep in mind, the FDA, people are prescribed 4 grams a day of either Leveza or Vasipa, which is the purified EPA, and that's very safe. So, this is a the omega-3, the way I like to think of it is it's got the safety profile of a nutrient, but it is pharmacologically active. And, and so many people are not getting enough of it. I think something like 80% globally do not get enough EPA and DHA, and like 95% of people in the US do not get enough. So very important in respect to the way we're aging. I think it's important for cardiovascular health. I think it's important for brain health and throughout the lifespan, from infancy to old age. Important. So that's sort of my spiel on omega-3. I think it's a very low hanging fruit and important thing that people can take in.
Well, thank you for doing some nutritional myth busting. I think you've made a compelling case that we should all be aware of our vitamin D status and our omega index. I think our audience will not forgive me if I don't dive into the supplement piece for just a minute. I saw a debate raging on a functional medicine group yesterday about whether or not omega supplements are contaminated with things like PCBs to the same degree that the whole fish would be, and if we need to be concerned about environmental toxicity in supplements. I would just love to hear your perspective.
Yeah, my perspective again is it's nice to get a quality supplement. And I think there's a few things that are important. One, I think triglyceride form. Leveza and Vasipa are in ethyl ester form. Ethyl ester is not incorporated into cell membranes quite as readily. It's not as bioavailable. It absolutely has to be taken with food, preferably with a higher fat meal. But, some people, if their doctor prescribes it, they're going to take it. And compliance is an issue. So triglyceride form is more bioavailable. It does incorporate into cell membranes much better. And I think that's important. Two, I think oxidation status. So fish oil is a polyunsaturated fatty acid. So it is prone to oxidation. There are isolation protocols that can be done that can minimize that oxidation, such as doing it under liquid nitrogen, for example. And there are third-party testing sites that will test omega-3 oxidation status, and they also test PCBs, mercury, and everything. I think the best one that I use is called the International Fish Oil Standards website. It's IFOS. And there's a ton of different brands on there. If you go to their products sheet, you can click on the product, and then they have batch numbers for all the different types of omega-3 supplements that are out there. And then you can then look at the raw data. You can look at their oxidation status. You can look at how high the mercury and PCBs are, all those things. I would say the most important thing is concentration of EPA and DHA, triglyceride form, and then, perhaps the oxidation status. I think because most of these fish oil supplements are purified, they're run through a column. They are purifying away a lot of these, toxins and stuff, that it's not as big of an issue. The most important thing, though, is the omega-3 fatty acids protect against the potential negative effects. Like I said, in the developing fetus, where they're so much more sensitive to the mercury, the PCBs, and everything, the omega-3 fatty acids are protecting. And that's the study I like to cite whenever I get that question about, but what about the toxins? But what about the toxins? It's like, here's the thing. Focus on what we need to be getting. Like, what are we, if you focus on the toxins, like you're not going to get any omega-3, or you're not going to be getting enough of it, And so, and I think that is way more detrimental than any little amount of, mercury or PCBs that are going to hitchhike in, because the omega-3s are so good at lowering inflammation. And that's kind of one of the major things that you're worried about with those things. I mean, it's to me, it's kind of like a levels thing, right? Where it's like, yeah, but you're getting so much more of that other thing that's going to negate, the potential negative effects of the PCBs and mercury. So IFOS, good source. Labdoor is another one. They kind of have a different, they like rank things. And so most of the time they're sold out of the most top ranked supplement, but you can go on IFOS and find tons of other supplement brands, and regionally. So like Canada, if you live in Canada, you'll find some that are found in Canada or Europe or US. And so I think that, go out there and find a supplement that makes you feel good. It's got a high level of EPA and DHA. It's got, low oxidation, perhaps lower mercury, and, and don't sweat the small stuff.
Very practical advice to help us choose a supplement. I think with your insights and the resources that you've shared, we have a good idea of what micronutrients we should focus on. So I'd like to shift our attention to exercise. I know you're interested in talking about that as well. Before we do that, in your work, you explore the benefits of certain types of stress that might include exercise or fasting or hot and cold therapies. And I thought it would be a good time to introduce this concept of hormesis. And I was hoping you could give us a little bit of a primer. What are we talking about when we refer to hormesis?
Yeah, it's a really, it's a term, I think it might have originated from some of the plant phytochemicals. There was a book, I forgot the author of the book, but it refers to exposure to a low level of something that at a very, very, very high level could be, I don't want to necessarily say toxic, but toxic. It could be bad for you. You're exposing yourself to so for example, exercise. Like everyone knows exercise is very beneficial. But if you were to just nonstop exercise 24 hours a day and keep doing that, like you would collapse. It would be bad, right? So exposing yourself to a little bit of stress, basically we have all these genes in our bodies that are activated in response to that stress. And these are antioxidant genes. They're genes involved in inflammation. So, anti-inflammatory genes. They're genes that are involved in clearing out damaged things. So this is autophagy. They're genes in repairing DNA. So all these things get activated. And the activation of these genes outshines the little bit of stress that you sort of applied to activate them. And so the net effect is beneficial. And throughout our human evolution, I guess, we have been exposed to these intermittent types of stress, whether it is periods of food scarcity because we didn't have Instacart and couldn't just order our food and have it delivered to us. We had to go out and hunt it and, find it, find berries and, vegetables and things. And so food scarcity, there were periods of times where we were fasting. We were not getting food. And that activates a variety of stress response genes. A lot of times these are called stress response genes, such as autophagy genes, which are clearing out a lot of damaged stuff within a cell, inside of a cell. And they're very robustly activated by fasting, but they're also activated by other things like heat stress. So that's one form. Then there's the physical activity, right? That also, again, we humans used to be a lot more physically active when that was our life, right? And we had to go and hunt and gather, and we worked in the fields, agriculture, farming. Just much more stuff that we were doing by moving around. That is another form of intermittent stress. Lots of stress response genes are activated. When you engage in physical activity, you do activate inflammatory cytokines, IL-6 being one of the big ones. But the response to IL-6 is the anti-inflammatory response. So IL-10 gets activated and it's more powerful. So it stays active for longer. And so the net effect is anti-inflammatory from the little bit of inflammation that you've generated by exercising. The other example is these plant phytochemicals. So these are compounds that are found in a variety of plants, sulforaphane being one in cruciferous plants. There's, the resveratrol is probably a very well-known one that's found in the skin of some fruits like grapes and blueberries. Pterostilbene, another one found in the skin of blueberries. There's the turmeric, the curcumin found in that. And so these are all phytochemicals that also activate stress response genes. They also activate genes that are active from things like physical activity or heat stress, like heat shock proteins. So a lot of overlap between the intermittent stress can activate a whole host of these things. Some of these stress response genes are more active by different types of it. So like thermal stress more robustly activates heat shock proteins than eating some broccoli does. But sulforaphane does activate heat shock proteins. Sulforaphane is found in broccoli sprouts. So you'll get a lot of overlap between them. But the bottom line is that our genes were meant to be pushed by intermittent types of stress. And we've lost that. We've lost that ability to push them. Not the ability, but we've stopped doing it. And I think that it's had a detrimental effect on the way that we're aging, our predisposition to age-related diseases as well, because you want to clean up stuff. You want to keep pushing the antioxidant, the anti-inflammatory, the preventing the protein aggregation, the repairing the damaged DNA. Like that stuff is important because all that stuff is happening every day just from normal metabolism, normal immune activation, normal going out in the sun and getting, ionizing radiation. And then you add on top of that modern day, living, air pollution, chemicals we're exposed to, it's compounding, and we have to turn those stress response genes on to not only age better, but to just even age normally. So it's very important to engage in, these intermittent types of stress, whether that's, exercising, cardiovascular exercise, resistance training, going into hot tubs in the sauna, not eating round the clock, having periods of a break, and also eating phytochemicals from plants. I think these are all very important.
Well, I think, as you said, we all know exercise is important, but when we look to healthy aging and longevity, are there types of exercise we should be focusing on? I heard you mention resistance training, but there's so many options: resistance training and high intensity interval training and aerobic training. Where should we focus our efforts?
It's a good question. And I think that, with respect to people, the people need to be physically active, whatever it is they're going to do, and do it regularly, routinely, establish a routine is, in my opinion, the most important thing. So not concerning yourself so much with, I need to be doing this zone 2, or I need to be doing high intensity interval training. What you need to do is do what you will do. That's the most important thing. But let's say you want to step up a level and you're already I'm committed. I, absolutely love the way I feel after I exercise, but I want to be doing the best things and trying to do everything I can to maximize every type of benefit for my brain and for my muscle and for my heart that I can. Right. So I'll say this, there's been these interesting studies that are called the vigorous intensity lifestyle physical activity. So VILPA. And, there's these large studies where people have worn these accelerometers, some sort of smart Fitbit or fill in the blank type of, device that'll measure their movement. And, it's been shown from these studies. So the vigorous intensity, this is basically not just walking. Okay. This is you're going to more of a, maximal heart rate or close to it. So you're more maybe 80%, estimated max heart rate, and doing something for anywhere 1 minute to 3 minutes, 3 times a day. Okay, so this is like the quote unquote exercise snacks. This is like, okay, I'm at my desk, I'm working at my computer. I'm going to get up and I'm going to do 1 minute of burpees, or I'm going to get up and I'm going to go sprint down the street and back, or I'm going to do a hill sprint, something that is so short but intense. And then you just get back into whatever you're doing. So it's not so disruptive. You don't have to have a gym membership. You don't have to go, and get in your car and drive somewhere. You don't have to like think about it and carve out time in your day. You just do it. You just get up from your desk and you do it. So this is 1 minute to 3 minutes, 3 times a day. Have shown that people that do this, again, this is measured by actual data, empirical data, have anywhere between a 30 to 40% lower all-cause mortality and cancer-related mortality. And to me, I find that very exciting because one, it's so doable. I think it's so doable for people, and creating an environment within, work communities, within maybe families, or wherever you spend the majority of your time, schools. I think that this is something that could be adopted by corporations, again, just by our environment that we're spending our time in, work or school. And it's going to be so beneficial for overall health. And not only that, you feel better after you exercise. And so the vigorous intensity is a little bit different than, some people like to go for long runs. They like to go for long bike rides. They're more of that, moderate intensity type of exercise. And that's great too. If that's what you're doing and that's what you love doing, there's tons of studies showing that being, physically active, particularly if you're going on a longer run and you're, engaging in 150 minutes of that normal, moderate type of aerobic exercise per week, that you're doing really good, right? So it's not that you have to go and do the vigorous intensity, although I do think there are added benefits on top of that. And those largely have to do with the brain, because when you are when you start to reach, above, when you're getting to the 80%, maximum heart rate, estimated maximum heart rate, and you start to get high, you can't generate energy from the oxygen that you breathe in quick enough. And so your mitochondria, which are the major source of energy generating organelles inside of your cells, they require oxygen to make ATP, which is the energy I'm talking about. So you can't get that oxygen quick enough for the mitochondria to do it. And so you're forced to make energy outside of the mitochondria, and you make it by using up glucose. And so the glucose then gets metabolized into lactate, and lactate is not a waste metabolite like it was widely believed for many years. Like, it's just waste metabolite. It's not only a waste metabolite, it could potentially be harmful because it was thought to be, causing muscle soreness. Complete and utter not true. Nonsense, not true. So lactate actually is a signaling molecule. It has been shown to activate brain-derived neurotrophic factor at the blood-brain barrier. It activates it. It also gets into other tissues, including the brain, through this MCT transporter. And it's used for neurotransmitter synthesis. Norepinephrine uses lactate, serotonin, dopamine. It's used for energy inside of neurons. It's used as a very efficient source of energy. So lactate can be used to make, energy. It's converted, inside the mitochondria and used as energy. And this is in the brain. This is in other tissues as well, like the gut. Lactate's really important for the gut. So I think that there's a role of high intensity interval training or vigorous types of exercise. I say high intensity interval training because it's hard to keep that level of activity up for more than an interval. I mean, it's extremely, you're pushing it all the way and then you taper down, right? So I do think the vigorous type of exercise has a special role in, I think, brain health as well. But also I think cancer prevention is a big one too. I mean, aerobic exercise is very important for cancer prevention. And specifically, I think that there's some interesting mechanisms where the intensity of exercise actually also seems to be important. So um, there's a circulating tumor cell. So these circulating tumor cells most of the time are when someone has a primary, tumor. So they basically have been diagnosed with cancer. And so at that point, the goal is, okay, well, how do we, get rid of the cancer and prevent metastasis, right? We don't want the cancer to spread. Well, these circulating tumor cells escape the primary tumor site, they get into circulation, and then they go elsewhere and then establish camp there, right? So the metastasis process. Well, exercise itself, there's something called shear force, the sheer force of blood flow going through the circulatory system itself kills these circulating tumor cells. And it does it because these tumor cells have these mechanoreceptors on their cell surface. And they're so sensitive to like movement. It's almost like a hurricane. It's like a hurricane just coming through and just wiping it out. And so that there's been studies showing that the people that have been diagnosed with either colon cancer or breast cancer, when they engage in intense physical activity, aerobic exercise, they are less likely to have their circulating tumor cells drop down. They're less likely to have cancer recurrence. I mean, dramatically in some cases, you're talking like 40%, and they're less likely to die from their cancer. So cancer prevention, but also important role for, cancer recurrence and cancer mortality for people that have already been diagnosed with cancer. I think that the big thing here, there's been a lot of, what type of exercise should I do? I think you should probably just, do what you can, do what you're going to do. Probably good to do both. Like I do a lot of Tabatas. And so I go between my all outs and also like, I'm in like a zone 3, sometimes a zone 2 when I'm sort of tapering it down and like before I'm about to go back all out again. And I do that 10 or 15 minutes a day, 5 days a week. And then I also like to do resistance training. And that's another, muscle mass and maintaining muscle mass, so important. And, building up that muscle reserve earlier in life, because it's kind of like, I forgot who it was. I think it was Brad Schoenfeld. He's an exercise physiologist that I had on my podcast. And he's a really an expert in resistance training. And he gave this analogy that I love that was like your retirement fund, right? Like you contribute to your 401k, you contribute so that when you're older, you have money there so that you can retire and live off of it. Well, muscle mass and even bone mass too, and resistance training is one of the best ways to build bone density as well. You got to build it up. And once you start to reach a certain age, it becomes very hard to gain muscle mass, although you can still gain strength. And so you have a harder time gaining that mass, but you're losing it. And so it's kind of like the more you start with, the losses aren't quite as big, right? So I think resistance training is very important for that as well. And it's something I've always been a aerobic exercise junkie. I love long runs. I haven't been doing as many long runs, and that mostly comes down to my lifestyle. I think once I became a mother, a working mother, it was much more challenging for me, certainly to go to the gym. Like that's way in my past. Like I have no time for gyms. But like even going for longer runs, I do still do that. I don't do it as frequently. Like it's more like, an occasional thing I do just because I love it. Now I find that it works with my schedule. Every morning I get on my Peloton bike every single morning during the week. And it's just a habit and I do it every day. And I feel amazing after. I feel sharp. Lactate is important again for neurotransmitter synthesis and stuff. And so, it's the feeling that I feel, mood as well. So, all those things are important. And I think that you have to find something that you can incorporate into your daily routine and that you will do. And, you want your heart rate to get up. You want to sweat. You want to be tired. You want to feel tired afterwards. And I think exercise, whatever way you can do it, where you are at least getting your heart rate up and you are flush in the face and you are when you're working out, you can't talk, right? To some degree, I think that's good. And there's been studies that have looked at, I think exercise can forgive a lot of sins. And I'll say this, during when I was a young, a new mother, my son was a newborn, and all the way up and through the first year, I mean, there was just so much disruption to my sleep and there's nothing you can do about it. I mean, like, we all know how important sleep is for health, for brain function, for blood pressure, everything, right? But when you're I can only speak as a mother. Like, I can't speak for being a father, but I think the father's sleep is also disrupted somewhat too. Mothers, though, they're breastfeeding. You have to feed your baby. There's nothing you can do. And in a way, if you think about all the detrimental effects, it can be very discouraging. You're like, I'm doing terrible things to myself, and there's nothing I can do about it. Well, I was wearing a continuous glucose monitor at the time, and my fasting blood glucose levels were just through the roof, and it was crazy. I was eating the same diet, and it wasn't until I got back into I was doing a lot of spin classes back then, and it wasn't until I got like on the Peloton or the exercise bike, doing high intensity interval training, that all of a sudden it normalized my blood glucose levels, even with the interrupted sleep. And then I went into the literature and found, studies showing high intensity interval training can basically ameliorate the negative effects of sleep deprivation on blood glucose regulation. And, so clearly scientific evidence of it. I had anecdotal evidence as well. But there's also was a pretty recent study looking at sleep and all-cause mortality. There's lots of those out there. You'll find, of course, people with disrupted sleep, shorter, much shorter sleep durations have a higher all-cause mortality. However, this recent study also looked at physical activity, and it was interesting because sleep, quality and quantity, again, was associated. So lower quantity was associated with higher all-cause mortality, but only in people that were not physically active. In other words, physical activity forgave the sleep disruption, the poor sleep. I think that if there's a message here, it is that the most important thing that you can do in your life is to sweat and get physically active. Like, there's nothing that is going to be better for you. No aging drug, nothing's going to be better than what exercise can do at the moment. And I think that is the main message, that like, you just need to be like, if you care about aging, everything from skin aging. Like, there was a study showing that people that are physically active are 20 to 50% less likely to have collagen breakdown. And I mean, it was just amazing. Everything, brain health, cardiovascular health, it's the most powerful, I would say, longevity drug you're going to get, in my opinion.
Rhonda, I so admire your passion for this topic, and this conversation today has made me feel so excited to see you present at our annual international conference. I wanted to thank you so much for sharing these real practical takeaways combined with the research briefs. We can't wait to see more, and we really look forward to seeing you in Orlando in June.
I look forward to it as well. It's going to be a fun time. Great conference coming up.
Thank you so much.
Thank you.
Did you know that IFM's annual international conference is the largest gathering of functional medicine practitioners in the world? Expert clinicians and thought leaders in medicine convene to pave a new path forward for improving health outcomes worldwide. Come join the conversation this June 1st through 3rd in Orlando, Florida, as we return to an in-person program. See you then.